Okay, here's another exam walkthrough from astronomy. The Sun is a yellow star with a surface temperature of about 6,000 Kelvin. In the 20th century, astronomers discovered a large variety of stars in our galaxy. Hertzsprung and Russell developed the Hertzsprung or HR diagram as a way of classifying stars, and HR diagram is shown below. Okay. It says label the x-axis of the HR diagram. You should include approximate values. Okay, so I want you to try this question out yourself, and then I will let you go at it, and then we will try the question ourselves. So first of all, what you need to do, the most important thing here, which first let's go with the basic thing. So this is temperature. Most of the students, you should know what this is. It is temperature. So this here is the Sun. It's found right here. Okay, and this is 6,000 Kelvin. So this is what most students will be able to do, because they know that this is the main sequence region, right? This is where the main sequence is, and this is where most of these stars are. They're in the main sequence, where they are stable, their core isn't contracting, and they're not becoming into red giants or red supergiants. None of that is happening, and they're so that's where most of the stars are found. Okay, now the reason it's this region that the Sun is because 1 L Sun is just the luminosity of Sun, okay, which is I think 3.88 times 10 to the power of 26 watts, something like that, because we just did that before, I think. Let me just sure. Yeah, so something like that. We just calculated it. So from that you can tell that 1 L is just the luminosity of the Sun. So the Sun has to be somewhere here. Okay? And then you can say that the Sun isn't really that hot compared to red supergiants, or it isn't as hot as a white dwarf, black dwarf. So it should be right in the middle. Okay, so that's how we come to the conclusion that okay, we have to put the Sun here. Now we should know one thing which many students don't know, is going this direction, because of the inverse logarithmic scale, this will actually be around, let's just go with the 15,000 Kelvin, and we can say this as, let's say, 2,000 Kelvin. Yeah. So you just gotta show the examiners that you know that this is going this direction, temperature will increase, and going this direction, temperature will decrease. Okay. So you have to show that to the examiner to get 1 mark. Then you have to show the Sun's position to get 1 mark, and then you have to show the temperature to get 1 mark. So these 2 marks are easy, but this mark is a little tough. So make sure you understand these graphs very well. Okay. So here's a graph from Save My Exams, and it's actually pretty good with everything given to you. You can see that we're going from hottest here to coldest or coolest here, and this is the white dwarf. This is the Sun here at around 6,000. We have the red giants, and above that we have red supergiants, and we have the main sequence obviously here. Okay, and then we have increasing brightness here as well. Okay, now on the y-axis we have the luminosity compared to the Sun's luminosity. So basically L over L Sun is what we have here. Okay, so for the next part we're going to be doing is we're going to be okay, so we have a couple of zones. We have Z1, Z2, Z3, Z4, and Z5. So a bunch of zones is given to us in the graph. Let me just erase this. So all of these zones are given to us in the graph, and we should know that this is just high temperature, and this is low temperature, guys. Okay. Now what you want to do here is they're saying you should match one zone with the description they gave you. Okay. Now let me just clear one thing. I'm going to explain this. Now the thing I want to clear is if you have high mass, you can see high mass means more area. And more area means more luminosity, okay, specifically the surface area. So if you have more surface area, you will radiate more light, okay. This will radiate less light because there is less surface area, because there is less mass, okay. So that's the first thing you have to understand. Second is, the more the temperature, the more the blue color will be visible, and the more you will be towards the left side of the graph, okay. So what we want to do here is, I want to say a couple of rules based on this. That is that if you have high mass, you will definitely have more luminosity, and if you have high temperature, you will be more to the left side of the graph, okay, left. Based on this, let's try to get these answers. So high mass, that means that something has to be like really either having high luminosity, okay, and it cannot have low luminosity, so it's not Z2 or Z5 here. So high mass means high luminosity. Then they say the star is hot as well. That means it's more to the left hand side. So high mass and high luminosity, which means the star needs to have a lot of mass and a lot of luminosity. Now we know we cannot go with Z3 region because that isn't the hottest, and neither does it have the high mass as well. So this is wrong, okay, because it doesn't have high mass here. We can see that there is another region, Z4, which has a higher mass, and the even higher mass is found in this region, which is Z1. This has even higher mass. Now, comparing Z1 and Z4, which has more mass? The one which has more luminosity. So the one which has high mass in comparison to the rest, and which is the hottest, is Z1. So that's the first one. The second says low mass and cool stars. So for this one, I'm looking for something that has low luminosity and low temperature, and I think you guys should know which is having the lowest luminosity and the lowest temperature. That is Z5. So we can go with that, Z5 region. The next region, it says, is low mass. So something that has low luminosity, okay. Now give me 1 second. So we already went through this. This cannot be the answer. We already went through this, okay. It's got to be one of these three, okay. So we have to pick something that has low mass. So it definitely cannot be Z4 because that's for high mass. We have high mass here as well. And it cannot be Z2. It actually can be Z2 because it says hot stars, okay. So we need hot stars. And if you see, this is high temperature, this is low temperature. So we need something that has low luminosity and which is more to the left. So this has, so it needs to have high temperature and low luminosity. So it's going to be Z2 as the next region. So I took my time to explain this. This is a little tricky. Okay, so that's the answer to this. So remember these rules when you answer this question. So in the final part of this question, we have to see the position of a star on the HR diagram changes as the star evolves. Explain how a star like the sun evolves as it progresses from Z3 to its final position on HR diagram. We know that this is the main sequence, and our sun is actually a low mass star, so it's gonna go into Z4 and become a red giant, and then go to Z2 to become a white dwarf. Okay, so it's gonna go from its main sequence. I'll explain all of this. Let's just divide it into a couple of parts. So main sequence, which is Z3, and then it's gonna go into red giant, which is gonna be Z4, and then finally the sun will become a white dwarf in Z5, and then eventually it will become a black dwarf. And the temperature will decrease. Okay, so this is how you should structure it. Now, for the main sequence star, it is powered by hydrogen, which undergoes nuclear fusion. Okay. Now, once hydrogen runs out, the fusion will cease. So this fusion will stop. Okay, or it will cease. Then what will happen is the core will contract due to the... So basically what will happen is the core will have high mass, and because of that there will be high gravitational forces, and because of that the core will contract. After that, the star will expand, so its luminosity will increase, and it will go into Z4, the zone. And then what will happen is the temperature, now the core will contract, so its volume will decrease. The core's volume decreases, so its pressure will increase. And because of that, the temperature of the core will increase. So when the temperature of the core increases, what will happen is that the helium will have enough temperature to undergo fusion. So now helium will undergo fusion, and when helium runs out, the fusion will stop, and that's when you will have no more temperature increase, and you will get actually a white dwarf at Z5. So after this no more fusion, you're going to have white dwarf, and then temperature will decrease and your star will become a black dwarf. Now if you do struggle with this, now I understand that there is a lot of stuff to memorize and understand. I recommend watching video and practicing a lot of these questions, and eventually, especially if you've studied IGCSE, this is just a repetition with just a little more detail, be it Cambridge, LXL or AQA. So please do solve a lot of questions and revise, and shouldn't